From Technological Institute of the Philippines, Group 2 present Laboratory Experiment Number 5 entitled Work Energy Theorem. The objective of this experiment is to determine and to compare the work done by gravitational force on an object to the change in kinetic energy of the object. The mass of the card was measured, then the linear track, angular indicator, and motion sensor was set up. The motion sensor was connected to the laptop. A dynamic cart was then positioned 10 centimeters from the motion sensor and released until it reaches the end stop. The part of the graph that showed constant changing of velocity was selected to get the change in velocity and the distance traveled by the dynamic cart. The work done by the force of gravity on the dynamic cart and the change in kinetic energy of the cart was then computed. Previous steps were repeated using different angles. The first table shows work done by the force of gravity on the dynamic cart and the change in kinetic energy of the cart computed in 3-degree angle. On the second table, the computed value on 6-degree angle for work done by the force of gravity on the dynamic cart and the change in kinetic energy of the cart was illustrated. The last table presents the work done by the force of gravity on the dynamic cart and the change in kinetic energy at 9-degree angle. The value of change in kinetic energy and the work done are almost equal. The work done is getting larger as the angle increases. The kinetic energy is unaffected by the increase in an angle.
The work done by the gravitational force is equal to the released mass by the system. This increases the potential energy which is conserved in the presence of the conservative energy, making the change in kinetic energy proportional to the quantity of work done. It is supported by the work energy theorem that implies that the total work on a system is equal to the change of energy in the system.